You're going to start today by remembering some factoring strategies. So you have 3 warm-up problems. You have x squared minus 16x plus 39. You have 8x squared plus 64x plus 120. And you have 5x squared plus x minus 48. So do whichever method you would like. You can do quadratic formula on all of them. Some of them you might be able to GCF and complete the square or whatever. Okay, you pick the way you want to factor, solve each of those problems. Check your answers with mine. For the first one, you should get 3 and 13. For your second one, you should get -5, -3. For the last one, we should get 3 and -16 over 5. Do we need to see any of them? The third one? Yes, the third one? Okay. So with the third one, we cannot basic factor. We're not going to complete the square. My middle term is not even, and there's a number out front. I don't want to mess with that. So and I can't use square roots because I do have a middle piece. So my other options are going to be slip and slide or quadratic formula. Okay, I'm going to do slip and slide. So if I slip 5 to the end and multiply to -48, we have x squared plus x, and this is -240 equals 0. So we got to find pieces that multiply to give us -240, but also add to give me a +1. Those numbers are -15 and +16. After this, we have to divide the 5 back out. So this factor becomes x minus 3. This factor becomes 5x plus 16. Make them both equal to 0. Bring this one out. That's how you get x equals +3. And on this side, we're going to subtract 16 and then divide by 5. Number 1 was 3 and 13. What was the GCF for number 2? 8. Yes, divide all your pieces by 8 first on number 2. Any other questions on your warm-up? We good? So yesterday we had real-world situations that we did solve by factoring. Today, we're going to solve them by graphing. Okay. A statistician for an outdoor company analyzes data for the years 2007 to 2014 to help inform the company about trends. The function r of x equals -14 x minus 4 squared plus 1,000 models the number of people ages 6 to 17 in tens of thousands, which is r, who listed running as a hobby for x years since 2007. Okay, so ages, who listed running as a hobby for x years. So how many and then how many years. Okay. Discuss with your partner. Well, hold on. Number 1, graph the function. So this is a lovely equation. What kind of form is this equation in? Is it in standard form? No. Is it in factored form? No, it's in vertex form. I can plot my vertex. Where's the vertex for this parabola? So this piece gives me a part of the vertex. This gives me part of the vertex. If it's inside the parentheses, we do the opposite. So my vertex is at +4 and +1,000. +4, +1,000. That is my vertex. Okay. We're going to use some key features to help us out, and we're going to use our calculators to help us find them. We're going to look for y-intercepts. That's going to help me. We're also going to look for x-intercepts, because if I know one on one side, I can do its mirror image on the other side. Okay? So, calculators. We have them. Let's use them. Ready? You should be on the y equals screen right here. We're going to type in the equation exactly as we see it. So remember, negative is down here at the bottom. Negative 14, parentheses, x minus 4, close your parentheses. To square it, if you see it's diagonal up from your 7 is the square button. And then we're going to do plus 1,000. So make sure your screen looks exactly like mine. So the square button is diagonal up from your 7. It's above log and next to your comma. We good? Are we okay? Yes. I'm about to move on. Yes. What? What about it? So you have to, it's diagonal up from your 7. That's right. Yeah. That's fine. We good? So you could push this and then 2 if you want. But this one just automatically puts it up there. That one's nice for your x squares. Okay, let's graph it. Graph. Oh no, I can't see it, right? Does your screen look like mine? That's all weird. We can change our window. So push the window button. All right? Look at the graph that's on your paper. Ah! How low do the x's go on your paper? What is that, negative 15-ish? Do you see that on the left-hand side? So I'm going to go from negative 15 on my x's. What's the highest x on your graph? 25. Okay. We're going to count by ones. Look at your y scale. How low do your y's go? Negative 200. How high do they go? 1,200, 1,200. We are not going to count by ones. That would be awful. It looks like it's counting by 50s. Do you agree with that? Do y'all see how I figured that out? Yes, so we're going to count by 50 here. Okay. We good? Do we match our window constraints? Because then push graph again. After it looks like this, push graph again. Push graph again. You should be able to see it. Go to the problem. Okay, so this is the very front, so it's negative. Okay, now fix your window. So you're going to go from, your x's go from negative 25 or negative 15 to positive 25. And your y's are going to go from negative 200 to positive 1,200. Yeah. All right, can we see our graph now? Can we see it? What's up? Okay. You got to do the exact same thing I do so that way it works. So let's go from the beginning. Make sure your equation is entered in the correct way. Make sure that's a negative sign out front, not a minus sign. Okay? Check your window. We go from negative 15 to positive 25. And then our y's are going from negative 200 to positive 1,200. We're counting by 50s because if you look at the scale on your notes, that's how they are counting. Right? There's 1, 2, 3, 4, right? Spaces between 0 and 200. So they're counting by 50s. Now push graph. Okay? Okay, so we can find different pieces on my graph. I can go to my table, right? And we can go up and down, seeing different things. If you ever get a 0 anywhere, that's going to show an x-intercept, but I don't see it happening. So like I know it happens in between negative 5 and negative 4, right? because my y's went from negative to positive. And then it looks like it's going to happen again between 12 and 13, so it's not whole numbers. Okay? So the table's a good place to look at. You can push the trace button. Okay? And we can go back and forth between different points. Okay? If you want an exact point, you're going to do second trace. Second calculate. Okay, we can find specific values. We can find zeros. We can find the maximum, the minimum. We can find where two lines or graphs intersect each other. For our vertex, we have it, but to find it, we would go to number 4. Click on maximum, because it's going to be the tallest spot. It wants you to click on the left of the vertex and then click on the right of the vertex. So you would go to the left a little bit, doesn't matter where, just on the left side, push enter. Then the bottom says right bound. You would go over to the other side. Okay, on the right side of the vertex, push enter. And then it says on there, do you want me to guess? Yes, I do. Push enter again, and it gives you an exact vertex of the 4 and the 1000 that we already have. Okay, we got that though from our function. Next, would you like to find the zeros of the graph? That would be helpful. So, second, trace. Do we all see this menu? Yes? Now go to 0. We want to find the zeros. Push enter. Which 0 do you want to find first? The negative one or the positive one? The positive one? Okay. Go down here. Again, it wants you to go to the left side and the right side of the intersection. Okay. So we're on the left side. We're going to push enter. Then we're going to go over. Push enter again. Notice the x-intercept. It's in between those two dotted lines that I just put on there. It has to be in between it. We push enter again. We get a 0 at 12.45. Okay, so 12.45-ish right here. Then you didn't put it the x-intercept in between the two lines. So go back to graph and try again. Push graph. That should show back up. Okay. So do second trace. We're going to find our other 0. I'm going to go all the way over here. Now to the other side. I want to go to the left bound. So on the left side of the x-intercept, push enter. On the right side of my x-intercept, enter. Again, my intercept is in between those two dotted lines that I just put on it. Okay? If you have those two dotted lines and what you're looking for is not in between them, it cannot find it. So that might have been the error possibly. Okay, so make sure it is in between. If it's in between, I mean, and it could be as wide as you want it to be. Okay? But I like to stay close. We want to find it right in the middle. Once it says guess, we want you to do that. Push enter. Negative 4.45 and 0.
So when I went to do that, it changed like the quadrant on my graph, and now it's not better.
All right, hold on. And then our y-intercept, we can just make our best guess. Our y-intercept looks to be about what? About, what, 760-ish, somewhere in between there. We can make our best guess.
What was our left thing?
I looked and made our best guess right there. We could also do second trace, find a value. So what do we want to look for? I want to find when x equals 0. Push enter. 776 exactly. So, but this time, so second trace, you want to find a specific value. So that's the very first option, number 1. If my value, and you can plug in any value for x. So if I want x to be 0, that's finding the y-intercept. And then I push enter, and it'll tell me if x is 0, then my y is 776. Okay, so 776. So we're going to have it here. And I'm going to mirror image that. 1, 2, 3, 4. 1, 2, 3, 4 on the other side. And do this. Not beautiful, but it's better looking than there. Remember, you also have a table of values. So we could have gone here also. You could plot some points here. Also, x equals 0 is also in my table. So our y-intercept will always be given to us there as well. Okay, and you can pick some of these points to plot. Notice where we go, see where x is 4? See how it's 4, 1,000? And then on both sides, it's 986. Both sides is 944. Both sides is 874. So that shows the vertex and how the values are repeating on both sides. Okay, so we've graphed it. How lovely. Discuss with your partner what constraints make sense for the context. Since X is years, since 2007, what are the only X's that we're worrying about? Positive ones up to what? We're only looking between 2007 and 2014, right? So the only X's that we care about are between 0 and 7, because that's going to refer to the years of 2007 to 2014. That's all we are looking at. What about my Y's? Is there any constraints on my Y's? X was years. What do the Y's represent? Number of people. We're not going to have negative people. Good. So my Y's have to be bigger than or equal to 0. Okay. Can't have negative people. Okay. So the quadratic shows just a function in its graph. Okay. If we're applying it to real world stuff, there's certain things that my graph cannot go to. Okay. Number 3, rewrite R of X in standard form. How could we do that? Yeah, we can expand this out, distribute, combine like terms. We've done this before. So negative 14 times x minus 4 times x minus 4 plus 1,000. FOIL those together. We get x squared minus 8x plus 16 plus 1,000. Gonna move it up this way. We're gonna have 2 more steps. Distribute that 14 all the way through. So we have negative 14x squared. What is negative 14 times negative 8? What is it? 112. And then what's negative 14 times 16? 221 or 4? Okay. And then our last little step is just going to be to add the 1,000. So we have negative 14x squared plus 112x plus 776. What was the 776? Do you remember? The y-intercepts. So does that make sense in our standard form? It does make sense because we already have that on there. All right, let's do as many key features as possible. Okay, as many key features as possible. Looking at our graph kind of brings back an old unit. What x-intercepts did we have? Yeah, negative 4.450. Those are exact, right? It said do not use approximate or rounded values. We actually found those in the calculator, so these are exact. My other x-intercept is 12.450, right? It was, but we're good. We're good. Go with me here. What else do we know? What's our y-intercept? 0.776. What else? It opens down. Okay. What is my vertex? 4 and 1,000. All right. What's your domain? Make sure we're with the context. What can my domain be? From 0 to 7. Okay, our domain can only be from 0 to 7. So we're going to bracket 0 to 7, bracket, which means what is my range going to be? Where are we at 7? We're looking from 0 to 7, right? That's all we can refer to. So 0 to 7, right? How low is my lowest y value? It's the y-intercept. What is it? 776. How high do my y's go? Up to 1,000. Where are we increasing? So we're only looking at this part, by the way. Remember, we use our x values. So we're increasing between 0 and 4. We're decreasing from 4 to 7. I'm not sure what that value is. Where are we positive? I would say all of it, right? That red section is above the x-axis. So it's all positive. My left in behavior is going towards what? Just the red section. Where are we going to? And where do we stop? 776, yeah. On the right side, where do we go and stop? Yes, yeah, we can definitely use this. Where is 7? Yeah, 874. So we're going towards 874. Whoops. There we go. We good? Questions on any of our key features? Okay. Number 5, draw the line y equals 650. Okay, so we can physically draw the line right here. Wish I had a straight edge. There we go. That's not 650, is it? That's 700. Sarah, hold on, we got this. 650. We can also draw it on our calculators. Bring those back up. Go back to y equals. You want to keep the parabola there. Go down to your next y and just put in the number 650. And then push graph. And it'll draw the line across for you. All right. Where do we think they are intersecting each other? It's kind of hard to see. But a good thing my calculator in second trace has the intersect option. You see that? Go down to intersect. Push enter. Okay. Move your cursor over to one of the intersections. and you're going to watch it jump. So I'm going to push enter. It's going to jump to the red. I'm going to push enter again. It's going to ask me if I want it to guess. I'm going to say yes. And it tells me -1 and 650. Exactly. So one of my solutions is -1. Right here. To get our other one, second trace, go down to intersect, push enter. Now I want the other one, so I'm going to move my cursor over. There we go, over here. Push enter. It jumps to the red. I'm going to push enter again. Do I want it to guess? Yes, I do. My other one is 9. Those are nice, pretty numbers. 9 and 650. So you have x equals -1 and x equals 9. Calculator questions for those. Okay. Yes. It should jump over. Are you like super close to it? It should jump automatically. So the intersect is nice. You get close to the intersect and you just push enter 3 times. You should be able to go boom, 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 and it should be able to tell you. Okay, here we go. So solve for time's sake, solve algebraically. We do get 9 and -1. We could solve by doing square roots. Okay, let's interpret our answers. Okay, I want to jump to interpreting. Interpret the solutions within the context. So we are talking about years, right? So the years 2006 and 2016. Where did I just get those numbers from? By adding the x's to our 2007, right? If we have x equals -1, we went back a year to 2006. X equals 9. I'm going to add 9 to 2007. So 2006 and 2016. In those years, it's predicted that how many people are going to do running as a hobby? It is predicted that how many people? Where did we get -1 and 9 from? The 650. And remember, it's in thousands. So it's predicted that 650,000 people age 6 to 17 run as a hobby. That's what those solutions mean. So x equals -1 shows the year 2006. X equals 9 gives me 2016. All right, discuss our solutions. Are any of them not viable? Is there any of them that I can't actually use? Yes. Why not? Can't negative people. What else? Well, because X isn't showing negative people. It's just showing the year 2006. We can't go back in time, but what is the constraint?
Since 2007.
Yeah. See? You see my little red piece up here? Versus my green dots? Are those within the time frame that they were looking at? No, they're only looking from 07 to 14. Okay? So the solutions are not appropriate. Neither one of them are. Because they are not in the constraint. They are not within the constraint of 2007 to 2014. Okay, the model starts at 07. And they only care about 07 to 14. They don't care about 2016. Okay. Let's go to the back. And I want to go look at number 6. We're going to go to the back and we're going to go to number 6. Okay. The top one on the back is very much like what we did on the front. You're welcome to practice that if you want. Number 6, though, already has the graph for you. This is what you're going to have on your homework. It has the quadratic and it has the line for you. Your homework only has the quadratic. Okay. So here we go. Aubrey and Parth are used graphing utility to determine the solution to negative 15x squared minus 75x plus 14,000 equals 6,500. Their graph is shown. Okay. What are the solutions to this? So I can zoom in. So we want to see where they intersect. What value is that? Looks like negative 25. And then where's the other side? This is still your notes, guys. And then we have 20. So we have x equals negative 25, and we have x equals 20. Okay. Which solution, if any, makes sense? So this is all tied to our top here. It is participation in soccer by Americans ages 6 and greater since 2007 can be modeled. Okay, so which solution makes sense for the context? The positive one, because my constraint was just anything past 07, right? So there wasn't an ending point. So 20 makes sense. It's in the constraint. Our constraint this time was anything bigger than 0. Okay. So we can expect the trend to continue 20 years after the year 2007.